In the previous video, we introduced how to add or subtract rational expressions. And again, the process is very similar to add or subtract fractions. So first we found the LCD, and then we equal the denominators, which means you change all the denominators to the LCD. And then you keep the denominator and add the numerators. So now we're going to look at some more examples. So when we have the variables in the denominator, and the process of looking for the LCD is the same as looking for the least common multiple for numbers. So we can break down each to find LCD or LCM. We break down each denominator. So the first denominator, 12a squared b, we can break down 12 as 2 times 2 times 3, and we break down a squared as a times a, and then there's a b. And next we can break down 3b squared. And 3 cannot be factored any further, so we line up a 3 with the 3 we have. B squared can be broken down as b times b. Lining up the first b and create a new column for another b, the second b. So the LCD or the LCM will be bring down one number or variable from each column we have. So now we have 2 times 2 times 3, it's 12, a times a squared, b times b squared. So that's the LCD. In this case, it's 12a squared b. Now, there's a quick tip to look for LCD is to look at the numbers first, the 12 and the 3, because we usually are familiar with the process of looking for LCM of these two numbers. So 12 and 3, the LCM, the least common multiple is 12. So we can determine that immediately. For the variables, the tip is you always take the one with the highest exponent. So for example, a squared, and the other one does not have a, which means a to the 0. So of course, comparing the exponent 2 and 0, we take a squared. And similarly, comparing b and b squared, and b squared has the higher exponent. So that's the tip. So without doing all this process, but that's just a quick tip. So let me put it down here. For the numbers, you would find the LCD the same way. For the variables, take the variable with every variable, you take the variable with the higher or the highest exponent. If you have 2, take the higher one. If you have 3, you take the highest exponent. So that will save you a little bit of time of expanding every exponent. Okay, so now let's equal the denominator. So in order to change all the denominator, each denominator to 12a squared b squared plus 12a squared b squared, the first one we can multiply by b, because when I compare them, 12 matches 12, a squared matches a squared, b does not match b squared. In order to get b squared, I need to multiply a b. So the top will give us 5b. And b times b will give us b squared we need. So after you multiply b with the original denominator, that will give us exactly 12a squared b squared. Now for the second denominator, first we need to get 12. 3 does not match 12, so let's multiply by 4. After we multiply 3 and 4, that will give us 12. And we don't have a squared here, so let's multiply a squared. And b squared, we already got b squared. B squared matches b squared. We don't need to multiply any b anymore. So that's just for a squared. And double check the bottom. 3 times 4 is 12. A squared is a squared. B squared is b squared. And the top will give us 7 times 4, which is 28. A times a squared, that's a cubed. So now we have the common denominator, 12a squared b squared. And we just add numerators, 5b plus 28a cubed. And again, this is already reduced because the top has nothing in common. We cannot factor it, and there's nothing we can the top cannot be factored, which means you cannot even find any common factor from the top and the bottom. Okay, so now let's look at more examples. So the first type we did was the denominators are still numbers. So when you look for LCD, it's exactly the same as before. So the second type, the denominators contain variables, but when we look for the LCD, the process is still the same as before. The only thing new is we may have variables in there. And the next type is the denominator may contain plus or minus. And in the previous two examples we did, n squared, there's no plus or minus in there. 3n, there's just 3 times n. 2 will just be 2. So in each denominator, there's not a plus or minus, or there's no more 2 terms. We only have one single term, which we call monomial. And the same here, 12 times. So we didn't have plus in the denominator. But in the rest of the examples, you will see like a plus 2, x minus 3, 2x minus 1. So there's always a plus in or minus in the denominator, which makes it a binomial, 2 terms. But when we look for the LCD, well, the first thing we're going to do is still break down each one. A cannot be broken down any further, so I would just be A. A plus 2, similarly, we cannot break down this for any further either, because you can check all the methods we have. GCF, A and 2, they have nothing in common. Difference 2 squares, there's no square at all. And also, it's not a difference. Third trinomial, we only have 2 terms, cannot be trinomial. And a grouping, well, we need 4 terms to do grouping, and apparently that's not grouping either. So A plus 2 actually cannot be broken down any further. So be careful. Factoring means you write it as something times something, but A plus 2 is just going to be A plus 2. Similar to a prime number, you cannot break down 5 as something times something except 1 times 5. So there's no other way to break down 5 as a product of 2 numbers with neither of them equal to 5. So same way, A plus 2 cannot be broken down any further with neither of them equal to A plus 2. The only way is just 1 times A plus 2. So let's see. The factors, let's look at the factors. So A plus 2, again, cannot be factored further. So the only way to just think of it as a prime number. Again, A plus 2 and A, these are, don't think of A as part of A plus 2 as a factor. A is a term of A plus 2, but not a factor. So when we look for LCD or LCM, we bring down 1 from each column. So we bring down A from the first column, we bring down A plus 2 from the second column, because A plus 2 together is a factor of A plus 2. So anything will be a factor of itself. So now you can see the LCD is actually A times A plus 2. So that's a little easier, because you would just, after you realize A is not factorable, A plus 2 is not factorable, you can just multiply them. A times A plus 2, that will give you LCD. So compared to the previous examples, it's sort of easier because you don't really have to do anything, just multiply them. Okay, so now we can equal the denominator, change out denominators to A times A plus 2. For the first fraction, well, rational expression, we will have to multiply by A plus 2, because we're missing A plus 2. And also put a parenthesis for A minus 2, because you're going to multiply both terms, these 2 terms with A plus 2. So that's going to be, let me copy it one more time. All right, so that's what we're going to end up with. Okay, for the second one, we're going to do the same thing. 4 over A plus 2, we need to multiply. In order to get a common denominator A there, so we need to multiply both top and the bottom by A. So we will have, I moved this A to the front to match with the first one, but you don't have to do that. You can just leave it where it is, because of the commutative property, A times A plus 2 is equal to A plus 2 times A. So now with the common denominator, A times A plus 2, we can simplify the numerators. Now here, because we have binomial times binomial, so let's do FOIL or distribution. So we get A squared plus 2A minus 3a minus 6 plus the second numerator 4a, because we keep the common denominator and add the numerators. Now we have a times a plus 2 in the denominator. Numerator, we found the like terms to combine. A squared is the only square term, but the a terms we have 2 minus 3, negative 1, plus 4, positive 3a. And there's a minus 6. So that would be the final answer. And you can take a quick look at the numerator. This one is not factorable. And if it's not factorable, you won't be able to cancel any common factor with the bottom either. Okay, now the next example will be very similar. Notice that x minus 3 is not factorable for the same reason as a plus 2. And 2x minus 1 is not factorable either, same reason. So you can check GCF, no GCF, not difference of two squares, not a trinomial, and it's not grouping. So that tells us if you try to break down x minus 3, you can't. It's just going to be x minus 3. And if you try to break down 2x minus 1, we cannot do that either. So you will create a new column for 2x minus 1. So the LCD or LCM will just be bring down from 1 from each column. So x minus 3 times 2x minus 1. Or it's just like you're multiplying these two. Okay, so we can take the first fraction or rational expression, multiply both top and bottom by, let me use a different color, in order to get this LCD, notice that we're missing 2x minus 1, so we just multiply by the other one, the other denominator, 2x minus 1. And in order to change the second denominator, 2x minus 1, to our LCD, x minus 3 times 2x minus 1. So we're just going to multiply x minus 3 here. Now we got what we need, the common denominator, x minus 3 times 2x minus 1. We just need to simplify the numerators. So first of all, we can go ahead and distribute. Well, let me just write down one more step to slow down here, because there's a place that we need to be careful. Okay, so now we can distribute to get 4x minus 2. And when we distribute this number right here, we are going to distribute negative 4 instead of positive 4. So that should give us a negative 4x plus 12 in the numerator. And combine like terms, 4x minus 4x, that's 0. 12 minus 2, that gives us 10. And then denominator, x minus 2 times 2x minus 1 can be left as it is. We don't need to multiply them out. So a common mistake is right here. Some students might just distribute 4 and to get 4x minus 12. And then instead of have a plus, they have a minus there. But they forgot there's another minus in front of the fraction. So this minus also needs to be distributed later. So be very careful with here. So minus times minus will give us a plus. Okay, so the last example we're going to do is a type that what if one of the number is not a fraction? So similar to what we did before. If it's not a fraction, we can make it a fraction. So how about we put a 1 under the number, so make it a fraction. Now let's look for the LCD. As we know, 1 goes into any number, any expression. The LCD would just be 3x minus 5. Again, 3x minus 5 is not factorable. Okay, so the LCD, we're going to change both denominators to 3x minus 5. Now, in order to do that, the first one, let me copy it down one more time. So the first fraction was negative 3 over 1. We multiply both top and the bottom by 3x minus 5. Okay. Now the second one is already 3x minus 5. There's nothing to do because it's already the same as the least common denominator. Just copy it. Now we can do the final step. 1 times 3x minus 5 will still be 3x minus 5. The numerator, we have to distribute negative 3 to get negative 9x plus 15 minus 4. And simplify the top. Keep the bottom, simplify the top. Combine like terms, that just give us plus 9.